Okay, so today we're going to be covering two important concepts in programming. We're going to be talking about loops and also conditionals. So both of these in Python are represented as code blocks, as we like to call them. And code blocks are simply just these little blocks of code that are indented, kind of like this. So this would be a code block right here. It's indented. It's one block of code. So in other languages, they may use curly braces or something else to denote these, but in Python, it's just indentation. So, let's first start by talking about conditionals. So a conditional is sort of a way that we decide which code we're going to execute and which code we're going to skip over. And code blocks in general are usually used as a sort of way of a control structure and how the code is executed. And conditionals are a very clear example of this. So we talked about last video these sort of Boolean expressions or logical expressions that evaluate the true or false. So a conditional, the way it's made up is structured with an if followed by some condition, and then if this condition is true, the code underneath it will execute. So here our condition is if x is greater than or equal to 5. That's our condition. Is this true? Well, we can go up here and see x is equal to 5, so this is true. So if we run this code, it's going to print that statement is true. So we'll run the code, and that statement is true. So that's the most basic sort of conditional you can think of. Just this one if statement with a Boolean. But there are some other conditionals as well. So sometimes we'll structure the conditional in such a way that we'll say, if this statement is not true, check if this statement is true. And this is what we call an else if, or an elif. So basically, if the first conditional is not true, check if this one is. Now, the first conditional is true, and this condition is also false, so this will not execute. And we can string together as many elifs as we would like, and it will keep going down looking for one of them that is true. But if it finds one that's true, it's going to stop going down that chain of elifs. And finally, if none of the statements are true, we also have this else statement. Now, this else statement will again only execute if none of the statements are true. It's the else statement. So here, one of the statements is true, so the else will not execute. But if, let's say, we came up here and we flipped this around, we made this false, well now our else statement is going to execute. It's going to say none of those are true. So let's wait. Give it a second. And oh wait, hold on. Get rid of this equals as well. My bad. So now it's going to say none of those are true. There we go. None of those are true. But also, I think it's important that we go into a little more detail about these sort of Boolean expressions, because we had a basic sort of look at them the last time around, but you should know that Boolean expressions, much like mathematical expressions, can be these sort of compound expressions, and we can link several Boolean statements together. So here we have this statement here, x equals 5, and y equals 3, both of which are true. And then because they're joined together by this AND statement, they effectively become one Boolean expression. So are both of these true? And then we can couple it with another Boolean, making this very large Boolean expression where if both of these are true or this is true, this entire statement will evaluate the truth. So you can use these sort of logical connection words, and, or, there's also not, which negates things. And using these connecting words, we can make more complicated expressions. So that's the basic idea behind if-else statements. Next, we're going to talk about loops. So in Python, there are two basic kinds of loops. We have the for loop and we have the while loop. So the for loop is pretty useful when you know how many times you want to iterate over something. Actually, first, let's back it up. What is a loop? A loop is just a code structure that repeats a segment of code repeatedly. And we call this iterating over the code. So let's say we have this loop right here. So this indented section right here is going to execute repeatedly because it's in the loop. So we have this for loop, and for loops are useful when you know how many times you want to loop over it in advance. So here, we want to loop over it 4 times. So this is going to print 4 times. And let's actually go up here and sort of comment all of these out, because we don't want them firing while we run this. So it printed it 4 times. So you might be wondering, okay, well, what's up with this syntax? We have for, which designates that's a for loop. But for loops, what they do is they effectively iterate over an iterable. Well, what is an iterable? An iterable is a data type that has smaller pieces of data within it in a sort of organized way. So you can think of an array. And what it will do is it will start at one end of the array, and it will make its way around the array. So every time it goes to a new element in the array, it's going to print this. So we have the pointer, which is I. I will start off pointing at the first instance of that iterable. So let's look at an example. See, we have this array down here. And this for loop is iterating over this array. So I is going to start off at 1. It's going to be pointing at 1, then it's going to print. And it's going to move to 2. Now it's pointing at 2, now it's pointing at 3, and now it's pointing at 4. So what the I in blank does is the I is a pointer inside of that iterable. So you might be wondering, what's with this range thing right here? Well, range is a built-in function, which we'll talk about in the next video, that generates a list of this size. So if we pass a 4 into it, it's going to create a list for us that has 4 elements. And then we're going to iterate over all 4 of those elements. That's why it prints 4 times, because there are 4 elements. The pointer executes at each element. So that's pretty helpful to know. So we'll come down here to the more sort of traditional use of for, and it's iterating over the array here. So if we print I, what's going to happen is that it's going to print each element. So it starts at 1, then it goes to 2, then 3. It's pointing at each element before executing. And you don't necessarily have to use the pointer in your loop. Like the previous loop we looked at, we didn't actually use I. We didn't need to know what was inside of the loop. It's just that we needed to loop 4 times, so that's why we created that new list. But here, we're actually using the contents of the loop within our list. Now, one thing that's very important that you realize is that I only points at the contents of the list. And we talked about pointers and references in a previous video. And if you didn't see that, you probably should, because it's a pretty important concept. So let's say we have this list here. We'll call it R. And it has these items in it. It's just a list of ones, okay? So if I equaled each of the elements in R, then we would expect that after we run this piece of code and we print R, that R is now going to be made up of 2's, because we go to every item in I, and then we add 1 to it, right? Well, let's look. No. Because what's happening is that I is only pointing at the element in R. And that's very important, because if we reassign I, we give I a new value, I isn't going to change the actual item it's pointing at, the actual object. Let's say I is pointing at this one right here. And you say, okay, we're going to take I and we're going to add 1 to it. Well, I isn't going to add 1 to this element right here. I is just going to create a new element and point at that. So this element's going to stay the same. If we actually want to manipulate the contents of the array, the only way to change an object, to change its value, is to use its pointer to change the fundamental object. So what do I mean by that? Well, here, the only way we could reassign one of the values in an array is if we reassign its index. And this is a very important concept in Python, because arrays in Python don't necessarily work the same way that they do in other languages. In other languages, if you have a block of memory, then an array is going to be a contiguous, connected block of memory. That's actually not how it works in Python. It uses this sort of dynamic array, where the array is really a bunch of references that are sort of coupled together. We have all these references sort of bundled together, and they're all pointing at different spots in the memory. So if we want to change one of the items in the array, we have to directly change what that reference is pointing at. And this is how we would do that. We create a for I in range, and now what the range function does is it generates a list where the list starts from 0 and it goes up to the number you inputted minus 1. So if this first array up here, it would generate a list of 0, 1, 2, 3. The list has a length of 4, but it starts at 0. And this is really helpful because when we index an array or a list in Python, the first index is 0. So if we create this here, it's going to generate a list that starts at 0 and goes all the way up to the last index of the array, correct? This is the length of the array. Okay, so now we can go through each index of our array and then have that index point at a new value, at its original value plus 1. So now that each index is pointing at a new value, we'll print it and we'll see the values actually change. Oh, hold on. R is not, oh, my mistake. Gotta make sure R is still defined. Alright, but now let's look at it. As you can see, everything has been increased by 1, because now we're actually changing what's being pointed at. And this is a very important concept. And then if you want to see what the range function actually does, we can print the sort of what it creates. And as you can see, it creates this list starting at 0, going up to the inputted number minus 1. So 0, 1, 2, 3, 4. So that's all it does. So this is a very important concept. If you have a for loop and you're looping over an iterable and you want to change the contents of the iterable, you have to index that iterable. If you don't, you're merely pointing at the values, and if you change the pointer's value, it's not going to change the actual contents of the iterable. I cannot tell you how many times this messed me up when I was starting off with Python. I could never figure out why. It was probably like a month into learning Python that I finally realized, oh wait, that's not how that works. It's when I learned that Python uses references with its variables. That's very, very important. If you want to change the contents, you actually have to go into the array's references and change what they point at. So now that we have that out of the way, let's look at the other kind of loop. And this loop is a little more basic. It's just the while loop. And the reason I paired conditionals with the loop episode is because while loops are based on conditionals. So a while loop, as you may have guessed, it loops while a conditional is true. So here, the conditional that x is less than 10. Well, if you come up here, look at x equals 5. Now you need to be very careful with while loops, because you need to ensure that inside of the loop, something happens that can make the conditional change. Because if the conditional doesn't change inside of the loop will keep going forever. And we don't want that to happen. So you need to ensure that the loop will sort of have something happen in it. Here, x is increased by 1 every time we loop through, so eventually x is going to be greater than 10, which is going to break the loop, which is good. So you might be wondering, why use a while loop? Well, while loops are useful when we don't know how often we want to loop. We don't know how many times we're going to need to loop. So if you have an array, obviously if you want to loop over that array, you would use a for loop, because you know exactly how many times you want to go over it. But here, with the while loop, we don't necessarily know. So this could be useful if you're making, say, a video game, and you want to play over, and say it's like turn-based, and you want to play the player's turns until someone wins the game or until there's a draw. Well, we don't know how long that's going to take. Say if you're playing tic-tac-toe. It could take any number of times until someone wins a game of tic-tac-toe. So we don't know how long that's going to take, so we'll use a while loop. So, in summary, what you learned today was if statements, which execute a block of code if a conditional is true, else if statements, which will check if their conditional is true only if the previous conditional is false. We looked at else statements, which will execute if none of the statements are true. And then we also covered loops, Looked at for loops, two main types of for loops where we iterate over the index of an iterable and iterate directly over the iterable and the differences between those two. And we also looked at the while loop, which is when we don't know how many times we want to iterate over something. So I think that was a pretty productive episode. Next video, we're going to be talking about functions. It's going to be probably a little bit of a shorter video. And then after that, hopefully we can get into some classes.